Good morning and good afternoon, depending on where you are. Thanks so much for being with us today and happy holidays. We appreciate all of you spending part of your day with us during this busy time of year. So today you're part of history. This is Bishop Fox's first in our new Tool Talk series, an interactive show and tell featuring popular offensive security tools. So get ready to follow along and learn more about Eyeballer, the tool that enables you to spend more time hacking and less time hunting. So we're just about to get started, but before I introduce our speakers, I'd like to run through a few housekeeping items. First, you'll see you have multiple engagement tools on your webcast dashboard. So the tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can also expand your live panel and slide area or maximize it to full screen by clicking on the arrows in the top right corner. So for today's presentation, we will be using the media player, so you may want to make sure that that remains front and center on your screen. If you have any questions throughout the webcast, and we encourage you to ask questions as you think of them, submit them through the Q&A engagement tool on the left, and we'll also open it up for more questions toward the end. If you experience any problems during the webcast, especially as they relate to audio or visual, please let us know using that same questions module. And you can also click on the Help Engagement tool at the bottom of your screen. If you want to share the webcast with your friends and colleagues, and we certainly encourage you to do so, we're recording it and we'll send out a link to the on-demand version shortly. And lastly, if you'd like more information about today's webcast or the Tool Talk about fuzzing coming up next month, just drop us a line at marketing@bishopfox.com or send us a private question in that same questions panel. So it's my pleasure to introduce our speakers today. First, I'd like to introduce you to Dan Petro. Dan is the lead researcher at Bishop Fox, where he focuses on application and network penetration testing, product security reviews, and cryptographic analysis. Dan has presented at several Black Hats and DEF CONs. Most recently, this past summer, he presented his IoT RNG research and has developed several open source tools in addition to Eyeballer. And if Dan's name sounds familiar, that's because he's been quoted in Wired, The Guardian, Business Insider, Dark Reading, Mashable, just to name a few. And we also have Joe Sekman. Joe is Bishop Fox's Associate VP of Research and Development, where he's responsible for nurturing a culture of innovation across Bishop Fox. With more than 20 years experience, Joe has amassed many security certifications, delivered several presentations, and he's co-authored multiple industry publications. Joe's also a prolific inventor. He has 2 patents pending and 8 granted patents. And my name is Jerry Kirshner, Senior Marketing Manager at Bishop Fox. So with that, let's dive into Eyeballer, and I will hand it over to Joe.
Thanks, Jerry. First, just wanted to state how when I first came to Bishop Fox, I had already heard about Eyeballer as a technique and a technology, and I was blown away just to learn more once I actually got here to see the ins and outs of it. Obviously very excited to meet and work with Dan as a colleague. That this is something that that you wanted to work on and create. So Dan, I'd like to share, or I'd like for you to share kind of what your response was there and kind of give a little history of where Eyeballer came from.
Yeah, it's a good question to start with. So certainly in this case, necessity was the mother of this invention. So we do a lot of what we call external network assessments at Bishop Fox. Basically trying to hack into some organization from the outside. With a very large scale scope. So sometimes that's thousands or perhaps tens of thousands, maybe even more than tens of thousands of IP addresses that are in scope. And so you really have a needle in a haystack problem, right? You've got to try to find the interesting pieces of surface area and get rid of all the uninteresting pieces of surface area. In many cases, these are web-like based targets that we're talking about here. So one common task that we find ourselves doing at Bishop Fox is you use some standard tools to find what ports are open amongst the IP addresses that we know are in scope, and then identify which of those are web ports. Then you use some pretty standard tools like Eyewitness or GoWitness that will use a headless Chrome to take screenshots of those exposed web interfaces. That way you can kind of get a sense of what is actually running there, right? You know that there's a web server in theory, but what is actually there? And so what you're left with is this mountain of screenshots. And usually that goes to some poor intern who has to kind of page through them one by one laboriously manually to find out like, well, this is just an IIS default page. This is uninteresting. This one actually looks like a real web application. Maybe there's something here. And so this sort of got us thinking like, this was kind of around the same time where a lot of the machine learning frameworks were like really starting to take hold, like really starting to come out. And we thought like, this sort of seems like a thing that we might be able to automate. It doesn't, like we want to try to find what's interesting amongst these screenshots, right? It's not, we're not looking for any particular thing. We're not looking to see, you know, like, is this exactly IIS or Apache or something like that? But we want to see like, you know, is this something worth pen testing? Does it have complexity behind it? So we started putting together some like heuristics around like, you know, what actually are we trying to look for here, and kind of came up with a few categories. And I put together a proof of concept to see if we could use a machine learning algorithm, in this case, TensorFlow, to try to automatically identify, to label those screenshots as this is a thing that is interesting and is perhaps likely to have complexity and therefore vulnerabilities, and this thing is not. That way you can kind of throw this tool at a very large mountain of screenshots, and it'll come back and tell you which are the interesting ones from that and which ones aren't.
That's definitely, from anybody who spent any amount of time as a pen tester, feels that pain and knows exactly where that's coming from. I know we've had Eyeballer out for a while, but new this year, we've released a couple new enhancements and features. So I'd like to just cut to the chase and hand it over to you for the demo and share your screen.
Yeah, so this is going to be a bit of a sing-along, if you will. So if you want to play along at home, you can. So if you go to eyeballer.bishopfox.com, there is a web interface that you can use yourself. So I'm just going to share my screen, and we can walk through some of the primary features of the tool. And I think being that this is a tool about screenshots, it's kind of inherently visual, so this should work pretty well. So, okay, I am sharing my screen. If you go to eyeballer.bishopfox.com, it just redirects to this page. So you can also just go to this page yourself. It's a GitHub IO page, so bishopfox.github.io/eyeballer. So I guess to understand a bit about how what Eyeballer is and how it works, a pretty good place to start is like what its labels are. So what is it actually trying to do from like a technical perspective? This is actually a good point to say. We'll have some questions at the end, like some time for Q&A. But if you'd like, this is a small enough crowd where we could probably just do questions in the middle as well. So if you have any questions, type them into the Q&A thing here, and then we can try to field those as they come. Eyeballer is written in Python. And it tries to identify 5 labels. So there are, I'll kind of walk through these individually. So the first are old-looking sites. This is a really good category. This is kind of like a you know it when you see it sort of category of like old websites have a certain je ne sais quoi behind them of like blocky frames and broken CSS. Like it has a certain look about it that says like, ooh, that looks like it was made in the late 90s or early 2000s, right? And, you know, things made, 2 decades ago are not just, poor looking, but they also tend to be pretty old and have a lot of vulnerabilities behind them. These are like vulnerability diamonds in the rough, just waiting to be found. And there's not any particular CVE that we're looking for again. These are like just kind of trying to find if a thing was made in an old manner. So this is like a really valuable thing that is very visually identifiable. Next is login pages. So you'd think that login pages are something that should be able to be found with a heuristic pretty well. Like if you just look for like a login field in the HTML. And you would be right to a certain extent, but you'd be surprised actually just how often those heuristics fail. And that's what we found. Is that in real world web applications, they're often built dynamically in the DOM with JavaScript. And so if you just look at the HTML statically, they're often going to be obfuscated and you just miss like so many login pages. And login pages are important from a security perspective because it's basically the web application telling you that there is additional functionality here that you cannot currently see, that you will have access to, but it's behind this layer of authentication. That's really valuable, right? So we know that there's more here. This is just the tip of the iceberg. and that's is pretty valuable to a pen tester. Also, it has a pretty actionable set of follow-ups. If there's a login page, if there's a login prompt on a web page, then we know exactly what to do next, right? We can try some common passwords. We can try enumerating based off of like known passwords for that particular client. There's a lot of things we can do here, right? So it's a pretty actionable set of follow-ups. The third label is a web application. So this is a kind of a custom sort of label that we came up with that tries to describe whether this is a web application, as in it has lots of functionality. So it looks, a bit something like this. See if this will blow up on me. Oh, this is a smaller version of it. Not important. So what this is trying to get at is, like, are there buttons to click here? Are there like functions, are there pages to peruse? Is there functionality here, right? A thick application, as opposed to just like a pure login page that has nothing else on it. And each one of these buttons, each one of these tabs, each one of these pages is more functionality that could potentially contain vulnerabilities. So these kind of web applications are really good to then follow up on with a real manual pen test. So again, Eyeballer is not trying to, be like Cylons. We're not trying to automatically penetrate these web applications using the machine learning. This is just kind of telling the pen tester, hey, there's complexity here. There's stuff, there's buttons to click on, there's search bars to search. There's things that could potentially go wrong, so follow up and look at them. So the next two labels are things that we actually probably don't care about and we'd like to remove from scope. The first are custom 404s. This came up when we frequently need to test to see whether a particular page exists on a server. So like one way of testing for particular CVEs, say like an exposed admin page. So if you want to see if there's like a Cold Fusion admin page, you go try browsing to website.com/admin.cfm is a common way of like seeing if an admin page exists. So we have tools that will do that sort of thing for us. And the page will return something. How do we know whether it was actually the admin page or not? So the first thing you might think about is like, well, what return code did the page return? Was it a 200 or a 404? But in practice, a lot of websites don't actually return error code 404s when the page doesn't exist. They have some cutesy 404 message that sort of looks like this, where it has like the letters, like has the numbers 404, but it's not actually in text on the page. And the HTTP response code is a 200. So this sort of frustrates your ability to automatically detect 404 pages. Nonetheless, it's kind of an uninteresting page. It's not something you actually care to penetrate, like to follow up on later. So it's something we'd sort of like to remove from like our list of interesting things. And Eyeballer can help do that. Because nonetheless, like you as a human being can look at this page and go, oh, that says 404. Or if it has a, a picture of a robot with like, like smoke coming out of its head and says oops on it. Like it doesn't have 404 anywhere on the page, but nonetheless, you know what that means, right? And so Eyeballer can try to pick up on that automatically. And then the last is a parked domain. So parked domains aren't actual like real websites. It's a thing that occurs when like a domain has like lapsed and or maybe the domain isn't lapsed, but they've chosen to put a parked site on it. Basically, they're just advertisements, sometimes links to other areas. But in any case, they're not like real functionality for our client that we would want to explore further, right? They're a thing that we'd like to kind of ignore and perhaps remove from scope. So the Eyeballer's ability to find the parked domains sort of fit into that.
Yeah, so and I also... Yeah, just sorry to interrupt here, Dan. Also, just to look at the common thread is classification of these screenshots and dealing with vast attack surfaces or vast environments that have thousands upon thousands of websites, as we discussed, really helps identify and prioritize areas to explore and expand upon further. This is also one of the techniques under the hood that Cosmos is employing as well in identifying and classifying target websites. So I just wanted to add that in here as well. It's a means, it's all about prioritization and speed and expediency and identifying what matters most to go through and test it out. So yeah, this is fantastic. Just wanted to add in a couple extra things. And Dan, new for this year there's the web interface aspect, right?
Yeah, that's right. So something that is new to iBaller, in addition to the Python code that you can see there on the GitHub, there's also this web interface. So we'll kind of walk through how this works. So the way, it's pretty straightforward. You just kind of drop files into this little drag and drop area right here in the front, and then it will do the classification for you. So without further ado, let's just kind of do it, and I'll show you what it looks like. So we just click on here. We can select a couple of screenshots to upload. I say upload, but importantly, as the text says here, there's no backend. So the way that this works is it's entirely static HTML and JavaScript. So all the processing is happening in your browser. It's not being like sent to a Bishop Fox server or anything like that for analysis. So the whole point behind iBaller is that you're supposed to be using it on sensitive data, right, on client data. And so it would be pretty useless if, in order to use it, you had to like ship all of your data out to like a Bishop Fox server. So then once that is done, it gives you the results here and each one of those labels. So if you'd like to use the web interface, you can just go to like iballer.bishopfox.com, or if you'd like to as well, you can just literally copy out the HTML and JavaScript and run it locally. It works equally well there. Turns out TensorFlow has a really nice JavaScript plugin that works in browser. So that's what you're seeing here. It actually does all of the machine learning parts, the TensorFlow stuff, just in browser itself. So then once each of these labels come back, you can export these out for use. So we can look at what each one of these is doing. So the default settings here will show you all web applications. So it basically must include, in order to be exported, it must be a web application, and will exclude all the custom 404s and park domains. But if you'd like to further clarify your selections, like I also want to see all the old looking websites, right? You can click on that. And now you can see there is one. So if we export this, it will give you a CSV file that has exactly that. So it has like a file in here that will have something that looks old looking. And then you can follow up on those screenshots. Yeah, go ahead.
Dan, sorry to interrupt. We have a great question here from another Dan. Can you say a little more about how the attack surface or complexity is defined? It sounds like it's primarily scored on the JavaScript on the web page, or a network level, or other attributes taken into account as well.
Yeah, that's a good question. So around specifically complexity, so we don't try to maybe that gets into a bit of like what is the training data, right? It's not that we score complexity exactly per se, as much as like it's fed in a large corpus of like screenshots of known web applications, so things that like we told the machine, involved a web application, and so like it tries to pick up on that. You're always whenever you're dealing with a neural network. You have a perennial problem of figuring out like what actually is the machine picking up on versus not picking up on. And in terms of when it comes to like iBaller, we're no exception. So what about a website makes it look web application-y is a really hard question to answer. So for other labels, for instance, login pages is a really good example of this, and the custom 404s, I know. We made I wonder if we have a reference to it on the website here. I don't. Yeah, I'd have to dig for it. So I came up with a method for trying to identify, like, basically debugging that exact problem. So it's a method of figuring out what on the website, what on the screenshot is keying, the model is keying in on to find out, like, this is the login page. So usually with a login page, there's a particular thing that is the login, right? Where the rest of the site is not a login, and there's one little area that is a login. So that's a really nice crunchy problem you can solve basically by occluding. So basically what we do is, this is a pretty common technique. You basically occlude, you draw a little box over the screenshot in the upper left-hand corner of the screenshot, right? And then classify it, and then move the box over a little bit, and then reclassify it, and then move the box over and reclassify it. And then you can watch the classification score as it dips down. And then eventually, once you have covered over the login page, your login score will drop way down. And then you can, from that, identify and create a heat map. So Eyeballer actually has a whole heat map method in it. That's an argument to it. I wish I had a better way to show that. I don't think I do in here. I won't spend time on it. But yeah, basically it has a method to do exactly that, to create a heat map of a particular image that will tell you where on the image it thought that the label was. But that tends to work better for things like logins, where there's one section of it that is the login or the rest isn't. Whereas with a web application, the whole image either is or is not a web application. So the heat map tends to not really work very well there. So I guess the kind of the reductive answer is that we know that it's a web application because it looks similar to our other training data. I guess web applications tend to have a couple of common functionalities, like tabs are a dead giveaway. Kind of this panel on the top tends to be a dead giveaway. That footers are a common feature of them. So I would guess that some of those are features that the model picks up on. But again, I guess I can't say that for sure.
Right, thanks. Back to the results.
So yeah, so I have here on the left a much larger set of data that I had classified just earlier than this. So you can throw in a functionally infinite amount of data onto this, and it'll classify just fine. Of course, because this takes place in browser and we're doing a live presentation, I didn't want to eat up all the CPU on my computer as we're doing this and then have trouble with the presentation. So I had done this ahead of time. Basically, you can plug around with these. So if you wanted to get, for instance, things that are web applications but are not login pages, you can do that here. Or things that are only login pages, you get 324 of these, and you can export those results to then look at those. And this will give you a pretty good sense of what is and isn't interesting from these, right? So you can remove 791 and 84 of these kind of uninteresting things. Or if you know that you only need web applications and nothing else, then that'll give you a smaller data set from that. And that kind of gets to the core of the Eyeballer, I think. So you can play around with this on your browser as we're talking here. Take a screenshot of a website and throw it in, or however you want to do that. There's a little note on here about what the resolution works best. 6:10 aspect ratio is default in the Go Witness tool, which is pretty common for taking screenshots automatically. So that's why that is the case. But it'll work to some extent no matter what the aspect ratio of the website is. Cool. So I guess with that, we've got a few minutes left to do some Q&A.
Okay. Let me up here. Okay. So one other question. You mentioned that Eyeballer operates under a neural network. What does the neural network model actually look like, and what are the layers and parameters associated with that?
Yeah, that's a question I get a lot. So the code here is all up on GitHub. So if you go to our GitHub, inside of here, there is the model file. And if you're familiar with TensorFlow or machine learning at all, this will all seem rather familiar. So we just use a pretty easy sequential network. And then there's let me try to make this a little bit bigger so you can probably see it better. There's really two things to kind of call out here. One is that we use the MobileNet as a front-end network, which is an interesting choice. MobileNet is, as the name suggests, meant for kind of lighter weight things. There are, in theory, better performing front-end convolutional layers, this front-end network. But in our testing, none of them seem to actually perform any better for our use case. and wind up just slowing down training time. This is an assumption, but my best guess as to why that is the case is that as far as the visual complexity goes, our task is actually pretty straightforward. It's not all that difficult. If you're trying to tell the difference between a cat and a dog, for instance, there's a lot of like visual nuances that the machine learning model has to pick up on. Like has to try to tell like where the snout is and whiskers and ears and all that stuff is rather very complex, right? And so the more detail and nuance that your model has, the better it is at picking up on like the difference between a cat and a dog. But when it comes to screenshots, it's a lot more straightforward. Oh, where's my cat sitting on the keyboard? We lost my place. Okay. With a mobile net, I think it's just a much simpler network. And so it winds up having similar performance across all the different front-end networks. And then from there, it's just a pretty standard series of dense layers and dropouts until you get to the labels. So you'll find in terms of machine learning, this is rather pedestrian. I'm not a like data scientist who works in like models specifically. But I sort of like to do this stuff on the side. So the machine learning has always been a great interest of mine, and I'm able to make these cool programs. I'm really more of an expert in computer security, but not necessarily an expert at novel applications of neural networks themselves. So the layers are pretty straightforward, as it turns out, and it worked. So I was pretty happy with it.
Excellent. And we have another question. It looks like this is open source, which is correct. Do you offer an enterprise version? What are the differences and features between the two offerings? Dan, I don't believe there's an enterprise offering outside of the open source version that's already included with Cosmos. So is that correct?
Yeah, that's correct. All the code is open source here at Bishop Fox. We're, fundamentally a services company. We don't like sell software. So everything that the web interface and the tool itself is all open source. Obviously, we offer plenty of services at Bishop Fox. So like with our Cosmos offering, like $5 is like part of the service, as well as just ordinary consulting stuff. So yeah, short answer, yeah, it's all open source.
And I know I've anecdotally heard too from friends in the industry of them taking iVoller and integrating it into their service offerings or their just their ability to deliver their service as well. And I think that there's been a couple presentations, I want to say B-Sides Atlanta in past, I can't remember exactly when it was, but there's also, there's a lot of, it's really neat to see the creative ways in which some of the tools that we've created get integrated in and used across the industry.
Absolutely.
Okay. So any more questions before we start winding down? Last call. All right, Dan, if you don't mind, I'll steal the screen back from you.
Yeah.
And questions, we've got answers. Okay. What is going on? I'm having some issues. And there we go. All right. Closing remarks. First, thank you, Dan, for joining us today to talk about iVoller. And thank you, everyone, for joining and taking part in this inaugural episode of our new Tool Talk series. Please make sure to click the registration link in the related content panel and join us for January's edition of Tool Talk, where I'll be joined by guest researcher Matt Keeley to talk about fuzzing. Thanks again. Bye.
Thanks a lot.